Hello there, this is Mr. Bad Hair Day Roche, and welcome to Mr. Roche's Flip Class Math 10 No Frills, No Thrills, Low Budget, Low Tech videos. Joining me today once again is Wilson, and he's going to be our camera guy and my faithful student. So I'm putting him over here. Let's look at what we're doing today. Well, we're starting a new unit. This one's called Linear Relations. This is part 1. Specifically, we'll be talking about line segments. And today we'll find out how to find the length of a line segment on a coordinate plane that is horizontal, vertical, or diagonal. Okay, so here we go. I've set out 3 examples to illustrate these 3 concepts. First of all, we'll start off with a horizontal line. I've just put little ticks to represent units instead of using an actual grid. So you can see here that we've got a horizontal line going from this point to this point. Remember, segments have endpoints. So we can find the length or the distance between one endpoint and another. So in this case, we've gone from -1 all the way up to +3. It's a simple matter of counting. 1, 2, 3, 4. That segment is 4 units long. Now if we wanted a formula, we could actually come up with one. So the length of AB, let's call this AB, the length of AB is equal to, well, let's give this some coordinates. A is -1, -1. And B is represented by the ordered pair 3, -1. Okay, you'll notice that the y value is the same. The y coordinate is the same for both. That's because it didn't go up or down. However, the x coordinate is different. If we take the difference of the x coordinates, we should get the length. So, if I say -1, subtract 3, -1, subtract 3, I would get -4. If I took the difference the other way, that would be 3 minus -1, I get 4. Now keep in mind that the length of AB is 4. You never call the distance between two things a negative number. For example, if Vancouver to Edmonton is 800 miles, we don't say Edmonton to Vancouver would be -800 miles. It's always a positive distance, okay, regardless of the sign here. So the length of AB is the difference in y coordinates. I'm sorry, the length of AB is the difference in x coordinates. So we have x of A minus x of B, or the other way around. Okay? Let's go to a vertical line. Well, here we can see that we've gone up 1, 2, 3, 4, 5, 6, 7. So the length of that must be 7 units. How would we find it mathematically? Well, let's call this M and N. Okay, so the M has coordinates 1, 2, 1, 2, 3, 4. And N has coordinates 1, 2, and 1, 2, -3. So this time we can see that the x coordinate has not changed, however the y has. So if we take the difference in the y coordinates, 4 minus -3, that's the same as 4 add 3, we get 7. Or -3 subtract 4 is -7. But remember, the distance is still +7. So then we can say the length of a vertical line, MN, is equal to YM minus YN. That should be consistent. Capital N. Okay. So this is if it is vertical, and this one is if it is horizontal. Hope that's simple enough. Now let's check out the diagonal one. Okay. I'm going to go back to calling this point A and B. So we want to know how long the line is going from A to B, that segment. we could do this through a simple process of problem solving. We could use Pythagoras. Okay. So if I draw a right triangle, okay, we know that a squared plus b squared will equal c squared. Okay? So I know how to find a vertical distance now. I know how to find a horizontal distance now. So that'll give us a and b. We can find c. So let's do it just through a problem-solving standpoint here. So we know that a squared plus b squared equals c squared. Okay, well let's find a. Well, that's the vertical distance. Well, we need some coordinates here. Let's find some coordinates. The coordinates of a are -1, -3. -1, -3. And the coordinates of b are 1, 2, 3, and 1, 2, 3, 4. Okay, so we already learned that we can find the vertical distance by subtracting the y coordinates. So 4, take away -3 equals 7. So a is 7. B is the horizontal distance, and we know we can find it by subtracting the x coordinates. So we have 3, I'll do the larger minus the smaller and end up with a positive that way. 3 minus -1 equals 4. Okay, so now if I put these numbers back into this formula, I have 7 squared plus 4 squared equals c squared. 49 plus 16 equals c squared. 65 equals c squared. So c is the root of 65, which is the exact distance from A to B. The approximate distance would be somewhere just over 8.1-ish, okay? But if they're asking for an exact distance, we'd leave it as a radical. Simplify if possible, that one's not simplifiable. Okay, so that's using a problem-solving kind of a methodology. What if we look for an actual formula that would work for this? Okay, let's start off with this again. If a squared plus b squared is c squared, obviously c squared equals a squared plus b squared. I just reversed it. And if I square root both sides, I have c equals the square root of a squared plus b squared. Okay, now let's start bringing in some of these things here. This time we're looking for the length of AB. So AB is C, okay, the hypotenuse of that right triangle, is equal to the square root of, well, A is the vertical distance. So we could say the y of point B. I'm just going to move that over a little bit. The y of point B minus the y of point A. Okay, that'll give me my A. And of course, I got to square that. There's that squared. Plus, to get my B, which is my horizontal difference or distance, my x of point B minus my x of point A, and that's squared. And of course, this could be the other way around. So this has actually got a name. It's called the distance formula. Lesson 2 in our workbook is about the distance formula. It's not actually something that we need to know in our Math 10 curriculum here in BC. But there it is in case you ever want to use it. We could find the same answer, of course, just with our problem solving that we did before. But now we can actually plug in these coordinates here. 4 minus -3 squared plus 3 minus -1. And we come up with that same answer of AB is equal to the square root of 65. Okay, that's it for now. Stay tuned for the next episode coming soon.